In this lecture, we take example of Jacobian. The question is find the Jacobian of xy with respect to r theta for the transformation x equal to r cos theta and y equal to r sin theta. We have given that x is equal to r cos theta. Let us give it equation number 1. And y is equal to r sin theta. Let us give it equation number 2. So now if we see in these two equations, here x and y are dependent variable which are depending upon the two independent variable r and theta. So now we have to first find out what is the Jacobian of the xy with respect to r theta. We know that the Jacobian of xy with respect to r theta is determinant of del x del r, del x del theta, del y del r, del y del theta. Now we want to find out what are the partial derivatives of x with respect to r, x with respect to theta, y with respect to r, and y with respect to theta using the equation number 1 and 2. So differentiating 1 and 2 partially with respect to r and theta respectively, we have first, what is the partial derivative of x with respect to r? So now if we find out the partial derivative of x with respect to r, cos theta is constant and derivative of r with respect to r is 1. So the del x del r is equal to cosine theta or cos theta. Similarly, if we want to find out the derivative of partial derivative of x with respect to theta, we consider r is constant and we know that what is the derivative of cosine theta? It is minus of sine theta. So the answer del x del theta is minus r sine theta. Similarly, if we take the partial derivative of y with respect to r, then the sine theta is constant and derivative of r equal to 1. So we are getting del y del r equal to sine theta. Similarly, del y del theta is derivative of sine theta is cos theta, so r cos theta. So these are the partial derivatives of the x and y with respect to r and theta. Now let us substitute all these values in equation number 3. Putting above values in equation number 3, we have Jacobian of xy with respect to r theta. So del x del r is nothing but cosine theta. Del x del theta is minus r sine theta. Del r del y is sine theta. And del y del theta is r cos theta. So let us simplify the determinant. So how to solve the determinant? We have to multiply the cross multiplication this into this minus this into this. So this is r cosine square theta and the minus and minus will become plus r sine square theta. Now if we take r common from both part, we have r times of cosine square theta plus sine square theta. And we know that by trigonometric identity, cos square theta plus sine square theta is 1. So the Jacobian of xy with respect to r theta is nothing but r. Therefore, Jacobian of xy with respect to r theta is r. This is the desired result. Thank you.